Hi folks, see you speaking again. Today we are going to have the second part of the project to make our little board with the displays. So the project is made of 5 steps or 5 sections. The first section was in the previous video, is the description of the whole project. And you are going to find it right here in the previous video. The second step was to make the list of parts and components and to gather them in case you really want to make the project. Okay? That's the step number 2. It's also done in the previous video. Next step is going to be to prepare the prototyping board. It's a mechanical part. The step 4, to solder the parts and the components. And the step 5, to see if it's working, to check it out. So now, let's start the step number 3. So this prototyping board is 10 holes by 24. And we need 21 holes on the horizontal. We don't need all the 24. Because of this, we're going to place it right here in a little vise. And we align it with the writing from the top hole to the bottom one, A, B, C, D, and so on. We are placing it right here. Now we're going to use a hacksaw blade. We don't need a hacksaw, just the blade is enough, because the prototyping board is made of a fiberglass reinforced epoxy resin, so it's pretty easy to cut. So the first cut we're going to do is, if you just count 3 holes, and you are going to start cutting somewhere on the 3rd hole, and we're going to make the adjustments at the end. At this stage, you may want to wear a mask just to make sure that you won't face the dust coming out of the fiberglass. So now we can start working. So it's very easy, because again the fiberglass, even if it said is reinforced, it's very easy to cut. You just have to make sure you don't go sideways. As you can see, you don't even need to apply too much pressure on it. Just a very slight pressure is good enough. You keep your mask on. We're almost ready. It didn't take long. We're going to adjust it at the end. We switch it on the other side. And on the other side, we just need to get rid of this part and up to the first row of holes. So we start cutting it. So as you can see, it's a very easy process actually, but I'm doing it together with you to make sure that everybody can see you can make it. So this is almost done. You don't need to apply much force. You take it out of the little vise. What you need next is a bit of sandpaper. You don't want to leave it like that. We're going to make it just a bit nicer. And at the same time, we're going to smooth the edges. Okay. We smooth the edges. We round the corners. It's extremely easy to do. By placing my hand around, I can figure that all the edges are clean. Okay, good enough. The other one, the other side. Get rid of the edges. We round the corners. So at this stage, it's just good enough. Now I'm going to clean it. And the job is done. Okay? We're ready for the step number 4. After the step number 3, where we cut and prepared the little board to solder, now is the step number 4 to solder the components. I have all of them right here in a box. I'm gonna dump them on my bench. And let's start it. Because soldering involves, of course, some solder and some flux. As you can see, there is a bit of fuming coming out. You may decide to use a fume extractor. As you can see, it's working just fine. But because we don't have much to solder, and to prevent the noise, I'm gonna put it off. There are just a few components to solder. Now, we start placing on the board the 2 IC sockets. They are 14 pin each, because this is the number of pins for our digits. Because these digits are not always extremely easy to find. I repeat that you can still find them on eBay with no problem. It's a very reasonable price for them. I think it's somewhere around 5-6 Canadian dollar each. We're going to put them on sockets to make sure that we can recover them and use them in another project if you need so. So then, I'm counting for the pin number 1. Remember the notch of any socket. I'm counting from the top. 1, 2, 3, 4, 5, 6, 7, 8, 9. In the 9th hole, I'm going to insert the socket. I'm going to put the other one adjacent to it. Is 1 row of holes remaining on each side for both. And short reminder about how do we solder. We want them to be well aligned. So for that reason, we only solder 1 pin. So we solder 1 pin for each. And then we check out on the other side to make sure that we align them properly. And this one. That's good. If you notice, this is just a very thin space between the 2 sockets. This is just to make sure that if by chance your packages are just a bit wider, they're going to perfectly fit. Once you do this, you can solder all the terminals for the 2 sockets. And I'm reminding you the technique to do, because these sockets, they contain a lot of plastic. It's not recommended to first of all, to hold the iron for too long, but then is an interesting rule to just solder each two pins to jump one pin, and then you go to the other socket and you do the same. If you think, you can even put it on a little vise. For me, I'm comfortable to solder them while they are not staying perfectly steady, but you can do this. So then it's gonna be obviously much easier to solder when you have more pins. So you solder in such a way that you won't hold the iron for too long. So as you can see, I jumped one pin every time. So after a couple of seconds, you leave them time to cool down. You go on the pins you didn't solder. Okay. And then there are still a couple of them to solder. I'm doing it slowly. There is no reason to rush, because the purpose is to get it done properly. Now we're checking all of them very quickly. I'm holding them about 1 second each to make sure they are perfectly covered. So I'm just checking if the sockets are soldered properly. You see, one by one. It doesn't take long. Now I switch it. I always want to be in the most comfortable position with my soldering hand. I can clean from time to time. And once the socket is soldered, this one is not covered. Once my sockets are soldered, we can pass to the next. Good. So now, we have the two sockets. And then, next part we are going to solder is this kind of header. I recovered it from my Arduino project. As you can see, this kind of header has very long pins. And yes, we are going to, let's use the other one. We're going to remove some of these pins. But because I have here a sample of the wiring, I have another one on my left on the screen, just to make sure. And this is exactly this one here. So in the very thin outline, I marked the missing pins. So total of 10 pins from left to right, but the second one on each side is taken out, and then the two in the middle are taken out. Before I'm doing this, I have to notice they are spaced 2 holes from the top of the socket, like this. And I'm going to place both of them, even if not all the pins are extracted as they should. So same situation here. Is going to be 1 hole between the socket and the headers. Now, the little trick here, several methods are there to keep the pins vertically. But the thing is, you don't need to put solder on the pins, because this side of the pins is the one entering on the breadboard later on. So you want to keep it as close as possible to the soldering pad. So I'm only soldering 1 pin on each. And once it's soldered, I'm checking out. It just happened this one here is soldered vertically, but not that one. And because of this, I'm holding it from another hole, from another side, which is not the one I soldered, and I melt the little pad of solder right here until I eventually find it vertically aligned. You give it a second to cool down. Now it's perfectly aligned. Once it's aligned, I'm going to also solder the one on the opposite side of it, right here, and the one on the opposite side of it over here. Now once it's done, now I'm removing the pins. How do we remove the pins? It's very easy. You just pick up a small plier, and with this plier, you remove the pins you need. I'm going to remove, take a look how easy it is, the ones in the middle. If by chance you're wrong and you're extracting out the pins, you can put them back, okay? So it's not the end of the world. Now I'm extracting the ones I don't need. It's not necessarily because I don't need them, but I'm taking them out simply because on the holes remaining behind, I'm going to pass some wiring. So now I have both of them, top and bottom, aligned exactly like here. Second one's missing, the two in the middle are missing. So it's absolutely symmetrical, so it doesn't matter what side you start, they're going to be the same. So once this is done, then you can put it back in the little vise, because you want to solder the remaining pins. It went out at my hand previously, because you don't have to use too much force in the vise. Now for the remaining pins, you can solder as close as possible to the pad. This is done. Now we go on the other side. So you solder all the remaining pins. These ones are required. You stay as close as possible to the pads. That's it. Good. So once this is done, you have now the pins, the long headers here on the board. Now you are going to need two other headers. These ones you are going to place from the other side. And if you take a look on the drawing, as it stays exactly like the original, as you can see. That's exactly like the first prototype I've made. From the top is going to be on the second row. So the top row is free to identify actually one more time what is the top, what is the bottom. And in the bottom is going to be, let me just identify it, it should be this one, on the last row, on the very last row. Now, once you have them here, you do exactly the same as before. You place them, and even if they don't necessarily stay perfectly aligned, you don't care about this. You just solder one pin on each side, and then we're going to easily align. So we take a look. This one is pretty good. Yeah, almost perfect. So then we can solder the other pins. It's going to be a similar story. We just solder the pins on the two extreme holes. That's good. And this time we're going to remove one pin, only one. If you hold it exactly like I'm holding here the original, it's exactly one pin missing. For this one, you count from my right 4 pins, and the fifth one you remove. 1, 2, 3, 4, and the fifth one you remove. It's going to be this one here. I remove one pin, and symmetrically on the other side, symmetrically, we're going to remove after 1, 2, 3, 4, the fifth one. Okay. And once this thing is done, then we can put it back in the little vise and solder the pins one by one. I skipped one here, and I skipped one here, and one more right here. Let's check it. It doesn't take long. Okay, now on the other side. just to make sure the plastic underneath won't heat up. You just skip from time to time, and then you come back and you solder the remaining ones. And you check if all of them are soldered. Second time I put my soldering tip. It's only for a short time, about 1 second every time. Good. Let's say it's done. Once it's done, we continue with the most delicate part, placing the diodes. Here you have to be careful. I know this kind of intelligent digits by heart. You don't have to. You are going to find the documentation attached. However, just to remind you from the previous video, on each of the two digits, there are 2 diodes. And the one on the pin 1 is a diode, a rectifier from the series 4000. Anything you have between 4001 to 4007, it doesn't matter. And this is for the pin 1, because the pin 1, remember from the previous video, is the one energizing the LEDs inside. And to just lower the voltage a bit, there's going to be a dropping over the diode, over the rectifier, 0.7 volts. So the diodes are going to actually be energized at about 4.3 volts. This way, they're going to hit a bit less. So remember, the acrylic material which is placed in the top won't crack over the years. So I just have here 2 of them recovered from my junk box. How do you place them though? You have to be very careful about that, because what do you have to do is to place them with the cathode to the digit. So the positive is going to come through the anode and passing the cathode. So if you accidentally energize it reverse way, they are going to be this way protected. Okay? So the diode actually exercises 2 functions. One function is to lower the voltage to energize LEDs, and the second function is going to be a kind of protection to the wrong connection. Okay, so these are the 2 rectifiers I'm going to place right here. So this is going to be exactly where the pin number 1 is going to go, and the other side is going to go right here in the top, So I'm going to cut this one off. Never direct the pins to your eyes when you cut, to make sure that there is no accident. For those of you having less experience in soldering, you may decide to use some goggles. So then you place it over here. Okay, the second diode is going to be in the same position as the first one for the pin number 1 of the second digit. And now we solder on the header in the very top. It's easier for you to see on the sample I already have. It's going to be soldered on the pin number 4, so you have to bend a bit. You have to bend a bit the pin, this one. And by doing so, I'm going to cut it right here. You see, I'm holding it so there is no chance for the pin to jump in my eyes or whatever else. Okay. It's good. So I'm folding a bit the pin to make sure it's dropping where it should. Right here and right here. So now with a bit of solder, we're going to place it in the right position. One here and the other one right here. Very good. So they are aligned with the cathode in the bottom. This is important because otherwise, if you don't do so, it's going to be relatively difficult to remove them after that. Good. So they both should go on the pin number 1. So when I fold them on the other side, I'm going to put them in such a position that they reach the position of the pin number 1. And this is exactly where are the missing pins, as you can notice, where are the missing pins on the second row of the headers. Okay. So once they're cut, you don't want to forget about the pins to be soldered. So you solder them right away before you pass to some other components. Very good. So then we solder exactly on the pin number 1. Okay, one's done and the other one is done. So we finished with these 2 diodes. And this is the main reason I did not solder at the same time the other diodes, because I wanted to prevent confusion. The other diodes though, I pick them also from here, are Schottky diodes, and the characteristic, one of the main characteristics of the Schottky diodes is that the voltage dropping across is only 0.1, maximum 0.15 volt. And these I'm going to only use for the protection, but they're going to be placed on the pin 14. What happens on the pin 14? There you energize the logic of the intelligent digits. What is the logic? Is the famous hexadecimal decoder to control the digits. So these ones are going to be placed exactly where is the missing pin on the second row. So the missing pin on the second row. Remember, they have to be aligned, is a must, with the cathode to the pin 14, exactly like this, because otherwise, if you put them in the reverse way, the decoder won't work. And the top row is the one, the top header is the one carrying the positive voltage. So all of them are going to be related together when you plug this one on the breadboard. Okay. As you can see, I always hold the pins. There is no chance for them to jump anywhere. Safety is the first concern. So then we're going to solder. We take our time to solder. So the diode has no chance to go anywhere else. It's right here. Same thing about the other one. Okay. This is done. Then the other side. And once it's done, you turn this board upside down, because you need the 2 pins, the cathodes of these diodes, to reach the pin 14. Okay. Then you do the same as before. You gently cut the terminals by holding them. I do this mechanically. You have to be very careful about this. You don't want the pins to jump nowhere else. Good. And once it's done, you place a bit of flux if you need. These terminals are much thicker than normal components, so they may remain a bit oxidized. This is why sometimes you may need a bit of flux on them. And then you attach them to the pin 14. Okay. Once this is done, we can pass to the next. Okay, what's the next? The next is, once the board is turned upside down already, as you can see it here, we should just follow the links on the solder side, because now again the board is, take a look again. This is the original. This is the original. And this is our project. And when everything is going to be turned upside down like this, we have to follow exactly the wiring which is over here. It's not that complicated, but this is going to be what I put here as the solder side, not the component side. The component side is the one obviously containing the parts. The solder side is this one here, where you can only have wiring. Okay, not too much wiring to do. And you just have to follow either this one or the printed one. Is the one you copy from the description of the previous video. And you just have to fill just a couple of wires until it's going to look like that. Okay? So I'm going to take a couple of minutes to do it, and then we pass to the step number 5, which is going to be to check it out. Okay, so supposing we finished the soldering, we give it a good look. You just need a visual checking to make sure you didn't accidentally touch wires or two adjacent holes. Okay, with a little scratcher, if you have any doubt, you can remove the remaining flux or solder. You give it a good brush. A toothbrush is perfect if you don't use it anymore. Don't brush your teeth after that, please. Okay. Good. So it's looking like that. Now we're going to make some room, because this was the step number 4, soldering, and we go for the step number 5, the last one, checking it out. Because everything looks soldered, we're going to place gently the 2 digits. They don't have to be placed final position, you just have to place them properly aligned. Okay, supposing they're good, top to top, aligned to the notch of the sockets, is looking exactly like the original, apparently, but we don't know yet unless we check it. And now there is the last trick we have to do. Okay, this was about soldering, and now the last trick is can also be found in the description of the previous video. Let me just access it over here. Okay, is this one. So in order for any breadboard to accept that project, you need to do some wiring. What is the purpose of this little wiring with jumpers over here? It's very well described exactly like that picture in the description of the previous video, so you can download the file yourself. Is because once you plug the project on the breadboard, you cannot place the typical wiring you're using everywhere. You cannot place it underneath. So these jumpers, their purpose is to give you access from outside the project to the 4 bits on each input of the intelligent display decoders. So then, when you do all that, you are going to nicely plug the project. How is this plugged then? Take a look how much room it's taking. It's taking exactly 2 groups of 5, exactly where I put the frame over here. So that's exactly what I'm doing right now. You don't need to fully plug it because it's going to be easier to remove it. And when you apply power, now it's showing 67, okay? Let's say I'm taking the digit on the right side. According to the chart I'm giving you here, if you use the same colors as I use, the orange represents the most significant bit. And for that reason, now I have these ones plugged everywhere. And if I'm just moving in the top, the most significant bit, because it was 7 before, now it's 7 was 0, 1, 1, 1. And now because all of them are ones, this is going to be the letter F. Let's check the other one. I have the same colors. So here I'm gonna do this one. Okay, so then I can change the display anytime I want. So then, one last check. I remove it from here. removing it, you have to be careful because it has a lot of pins on the headers. It has a lot of pins on the headers, okay? And I'm going to check it versus the original project. Okay, power on, take a look. I have the same. So here, if I just move it here, I'm gonna get the 7, you see, exactly as before. Because it's 0, 1, 1, 1, now I have 1, 1, 1, 1, okay? Which is 15, and this is represented by the letter F. And if I move this one over here, I'm gonna have to F, and if I move it this one over here, I'm gonna have 6F, okay? If I'm moving this one over here, I'm gonna have 7F, okay? So the display is going to change accordingly, okay? So far so good. So this is the original. Power off again. And this is the new one. We mount it here one more time. And it should look the same. You see, 7F. And one last check for this is going to be we put them aside, put this one away, and we pick up the original project over here. This is the one we've made. We place it over here. You see the room is exactly the same, 2 groups of 5, and there is some wiring over here to get access to the input pins. Okay. So when we place it over here, let me say 5 volt everywhere. Good. So same display here as it is here. Good news. Reset. We count up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We count down. It goes to 99, 98, and so on. Everything is fine. Power off. We remove our new project. Because if anybody thinks this one accidentally may be the original, we remove it from here. That's it. We put the other one instead, and both of them should work the same way exactly. Okay. This is our last checking. Power on. It doesn't matter what it shows, but it shows the same on both displays. So count up to 10, count down, below 10, 99, and so on. That's it. So now I have 2 of them available. Anytime I need to use this kind of little project, I can make a counter or shift register or whatever I need to do, and I have 2 displays available. So stay tuned for the next time. We're gonna make another one. Thank you very much for today. Bye-bye.